All right, this video is to go over the drawing vectors as scale notes. So the whole goal of this video is to show you how to solve for your resultant vector by drawing your vectors to scale using a ruler and a protractor. In order to do this, there's a few rules you need to follow. The first is that you need to pick a scale to represent your vectors. Make it simple, make it appropriate. And it varies by the question as to what you're working with. For instance, if we're in miles in our question, like it's a car drove so many miles, we're not going to be able to draw in miles. We might use one for every 1 mile, we're drawing 1 centimeter. Or if we're in, we could use inches instead of centimeters. The scale, though, is up to you. I often find myself using centimeters whenever possible. The second thing is I need you to draw your vectors as arrows. Oftentimes I see students just drawing them as lines, but the appropriate way to draw vectors is arrows, and your arrows should point the direction of motion. And what often happens if you draw them just as lines and not arrows is when you're at the end trying to determine your direction, you don't know which way it's going to go because you fail to point your, to draw your arrows pointing in the right direction. So anyway, third thing is you're going to use a protractor to draw your arrows in the correct direction at that angle. If it's not a 90-degree turn, we'll need to use a protractor. So to properly use a protractor, just to familiarize yourself with it, you have your straight side and your curved side. Your curved side has 2 rows of numbers. One side will start from the left, from 0, and go all the way to 180. And the other side will start at 0 on the inner side and go the opposite way. The row numbers you're always going to pick is whichever row is below 90. So if I'm on this side, I'd pick the top row because those are below 90. If I'm measuring something over here, I'd go bottom side because those are below 90. You'll never give me an angle that's above 90. And then on your straight side, you'll have your center mark as the hole. It's hard to see on the camera here, but there's a hole right here. And then the black lines coming off of that is where you're going to line up your angle. So for instance, if I'm measuring this right here, I'm going to line up that center mark, my vertex of my angle, and then put my straight lines on either going north and south or east and west. So in this case, this line is going straight east. I'm going to line up my center mark and that line with that. And then I'm going to go down from here. My curved side will go with my arrow. So my arrow will point out. I kind of follow it through, and it's looking like it's going to be at about 35 degrees. So this angle here would be 35 degrees. So that is how you use your protractor. For vectors, we also need to state the compass portion of it, so it's not just going to be 35 degrees. So if I look at it like on a compass, this is the east axis right here. That's below it, so this would be 35 degrees south of east. All right. All right, so moving on to drawing to scale. First up, again, we're going to pick an appropriate scale that fits the question. We're going to use a ruler and a protractor, and then when we're drawing, we're going to start at the tip of one arrow. We're going to draw the first arrow, then at the end of that, draw the second arrow, one after the next. So if I'm going like one, and then after the next, like that. They're not all just radiating off the same spot. We're going to connect those vectors starting from the tail end of one to the first and the other. So we're going to start, if we started here, and we ended there, this arrow here would be our resultant vector. And then we're going to measure the magnitude with our ruler, and then we're going to measure the angle with our protractor like we just did previously in the video. And then your final answer needs to include both magnitude and the direction because it is a vector, it's not a scalar, so it's got to have both. So, all right, so let's work out the first example. We have a bear wandering 2 kilometers south, then turns and goes 4 kilometers west before going 5 kilometers north. And ultimately, we're finding the resultant vector of the bear's travels. So for my scale, I'm going to pick 1 kilometer equals 1 centimeter and make it easy. So I'm going to start down here, trying to give myself enough space. So I go 2 centimeters south or 2 kilometers south. And I like to label them as I go so I know what's what. Then I'm going to turn and go west 4 kilometers, so it's going to be 4 centimeters. I'm going to try to get that a nice 90-degree angle right there. And then lastly, 5 kilometers north. And those are my component vectors. So now for my resultant vector, I'm going to go from start to finish. Use a ruler always, and then it's going to point. I'm started drawing here, I ended here. So I'm going to start my resultant vector from the same place I started, same place I ended. So ultimately the bear, he went down, over, and up, same thing as if he went just straight there. So that's drawing it out. Now to find your magnitude, you're going to measure with a ruler. So I'm going to take my ruler and measure, and looks like it's just under 5. It looks like it's about 4.9 centimeters. which with my scale of 1 kilometer, 1 centimeter, that would be 4.9 kilometers. So for my magnitude, it would be 4.9 kilometers. And then I need to find the direction he's going. The direction you're going to pick is always where you started from. So if I put a compass right here, I can measure, there's 2 angles I can pick from to measure. I can either pick this upper angle here off the north axis, or I can pick this lower angle off the west axis. Either one is going to get me a correct answer, and I'm going to show you both of them. So to measure this upper angle, and take my protractor and hold it to the side, like a backwards D, line up these black marks with my north and south axis, and then this is measuring from here over, and I can see it's right about 50 degrees. So this would be 50 degrees west of south, and that would be my final answer. If I had instead chose to measure this lower angle, I would turn my protractor this way with the curved part facing upwards, line up my black marks with east and west, and then follow my arrow out, and I'm going to pick the number less than 90. So I'm going to see, oh, it's right at 40 degrees. So it could be 40 degrees. Sorry, I just realized I wrote that wrong. That should be west and north. And this one would be north of west. So for your final answer, it'd be 4.9 kilometers at 50 degrees west of north, or 4.9 kilometers at 40 degrees north of west. You do not need to give both answers. One or the other would be appropriate. Also with these questions, there's a lot of room for just small errors. So there's an acceptable range that I would accept on a test or a quiz. For instance, if you got 5 instead of 4.9, or you got 4.8, that would be fine. If you got an angle very close to these, that would also be acceptable. The range is not exact because it varies by the question, but just know there's an acceptable range that you don't have to be spot on to my answer, but you should be very, very close to it. So, but that is how you solve a resultant vector by drawing it to scale.